Okay, this video covers Chapter 5, Section 1, which is solving systems of equations. Whenever you have two or more equations, they may have several different options. They may have a common point, in this case, is 2, 3, a solution to both of those. All you do is plug it in the top one. And you find out, yes, it does work. 2 plus 3 does make 5. Put it in the bottom one. 4 minus 3 is 1, so yes, it does work in both of those equations. Now, whenever you have two lines, they can intersect, and you can have one solution. Or they can be parallel and have no solutions. Or they can overlap and have an infinite number of solutions because they're the same everywhere. Now, algebraically, what's going to happen, if you'll put both equations into slope-intercept form, if it's lines, they're not consistent or no solution if they have the same slope because they're not going to intersect. They have infinite solutions if they're the same line, and neither one of those happen, and there's one solution if they have different slopes. So, for example, if you take negative 2x plus 4y equals 7, if you rearrange these, the top one should become y is equal to 1/2 x plus 7/4. The bottom one is going to become y equals 1/2 x also plus 7/4. Those are the same lines. You're going to have infinite solutions. This one, if we rearrange the top one, you'll get y equals 2x minus 5. The bottom one is y equals 2x minus 7/2. They have the same slope, but different intercepts, which means they're going to be parallel. And they're not consistent. They're not going to have any intersection points. You can also solve by graphing on a calculator. If you'll type in 3x minus 1 and negative 2x plus 3, when you graph those, you can see how many points they have. Using zoom decimal is a nice, easy way to find that and then trace the exact points. In this particular case, it should intersect at 1, 2. Now we have solving by substitution. That's if you solve one of them for a specific letter. Now I'm going to solve the top one for y because it has a 1 coefficient, and you get y equals negative 2x plus 3. I'm going to take that and put it in the bottom one. Now I circle what I'm solving and I'm substituting. So I'm going to take this negative 2x plus 3 and put it where y is. So I have 4x minus my negative 2x plus 3 equals 5. Distribute your negative and combine like terms. Gives you 6x minus 3 equals 5. Add 3, 6x is equal to 8. Divide by 6 rather, and you get 4/3. You're going to take that, put it back where the circle is, and you get negative 2 times 4/3 plus 3. And that should turn out to be 1/3 if I did that right. So your answer is 4/3, 1/3. Okay, elimination, that's when you line them up and either add or subtract. Hopefully add combined terms and something disappears. Now, if you have a 2x and a 4x, nothing will disappear, so you're going to have to do something by multiplication first. Now, I'm going to multiply the bottom by 2, and then the y's will cancel. So you have 2x, 2y, negative 5. Multiply the bottom by 2 gives you 8 minus 2 equals 10. Then when you combine those, you get 10x. The y's go away, and you get 5. So when you divide, x is 1/2. You can take this answer and plug it back in any place up here at the top that you want to. I happen to go back up to the very, very top. 2 times 1/2 plus 2y equals negative 5. If you subtract that, it gives you negative 6 divided by 2, so y is negative 3. So your endpoint is 1/2 and negative 3. That's where they intersect. Okay, elimination. Just another problem. This one, you can't just multiply by a single number. You have to multiply the top and the bottom. Top by negative 3, bottom by 2. That's going to make the y's cancel. Again, top top by 3 times 2 is 6, bottom by 2 times 3 is 6. I happen to pick the top one as the negative one. 3 times 3 is 9, 3 times 2 is 6, 3 times 2 is 6, 2 times 4 is 8, 2 times 3 is 6, 2 times 2 is 4. Combining those terms, you get negative x and negative 2, so x is 2. And again, you can go back up to any of these. I again happen to pick the top equation. 3 times 2 plus 2y equals 2. That's 6. If you subtract, makes negative 4. Divide by 2, so y equals negative 2. So x is 2 and y is negative 2. That's elimination. Now you can have 3 variable systems. You just have to pick 2 equations at a time. Now I'm going to take the top one and the middle one. So I'm going to take these two and combine them. And when I combine them, the x's become 2x, 2z's equals 2. I'm going to do the same thing, except I'm going to combine the middle one and the bottom one. Or in this case, 2 middles, because I need the y's to disappear. So I get 2 of the middle ones, 2x, 2y, 2z equals 0. The bottom one, x, 2y, and z equals 3. When you combine those, you get 3x plus z equals 3. Now we need these to cancel and get rid of either z or x. So I'm going to take negative 2 of the second ones. So I get 2 plus 2 equals 2. Negative 6 minus 2, negative 6. When you combine those, x is negative, or x is positive 1 when you divide. Now take this, put it back into any of these answers that have the z and the x in them. Since x was 1, z is going to be 0. Then take those answers, go back up. I'm going to pick the top one. 1 plus y plus 0 equals 2, which means y is equal to 1. So that's your triple. 1 and 1 and 0. 3 variable systems take longer, but they can be done. Okay, to solve this 3 variable equation, again I'm going to take the top and subtract the middle, put negative, and that'll get rid of my c's. So I get a minus 4a is negative 3a, b minus 2b is negative b, c's go away, and negative 9. And you can change those all to positive if you'd like to. Now suppose I take the top and the bottom. Now, since I wanted to get rid of c, I need to subtract those, because my c's won't cancel otherwise. So a minus a disappears, b plus b is 2b, c's disappear, so I get 2b is 6, divide it out, so b is 3. I can take this answer and go back here, because I know what b is. So negative 3a minus b, which is 3, is equal to negative 9. Add the 3 makes 6. Divide by negative 3 makes 2. So now I have my a and my b, and I can plug back in the top. A plus b plus c equals 4. A plus 3 plus c equals 4. I know a is 2. So it should be 2 and 3 is 5. Subtract, so c is negative 1. So it's 2, 3, and negative 1. So that's how you solve multiple equations.